Okay, let's get going. Good afternoon, everybody. Can you guys hear me? Good? All right. Well, let's get started so we can start on time and we can end on time, hopefully. Today we're going to be talking about real-world MVD use cases with Creo Parametric and ISO QIF, and we'll introduce ourselves in the following slides.
My name is Rudy Lozano. I'm one of the account managers at Capvidia. So you can see I'm not the person in the picture, but I'm here to talk as much as we can about MVD today. So we're going to be talking about the whole ecosystem of MVD. We're a software company. We support both aerospace. You can see the companies that we've been supporting right now with basic projects on MVD and very complex, in-depth projects. So we'll be at the booth today. If you want to stop by, we can keep the conversation going. Evan, go ahead.
Yeah, so my name is Evan Kessick. I'm a model-based enterprise and model-based definition subject matter expert at Belcan. I know my title's a mouthful. But Belcan is a global company. We have over 10,000 professionals supporting 900 active customers in the industry of aerospace, defense, automotive, and even into consumer goods. So we support our customers with engineering solutions, and I want to highlight my group, which is the Software and Digital Engineering Solutions Group, where we have hired and brought on a team of experts that can help with our customers wherever they're at on their digital transformation journey. So if you have any questions, feel free to reach out to me after the presentation. So before we begin, I want to talk to you guys about the importance of a digital transformation. And this study shows that digital transformation techniques could save manufacturers $57.4 billion annually. And now there's a lot of key enablers that contribute to this statistic. And today we're going to highlight and focus on the improved interoperability of engineering data. So in our presentation today, we're going to talk through some of the shortcomings that one will face with the interoperability of engineering data, and then how, through the use of Creo Parametric and MVD and ISO QIF, we can resolve these shortcomings. So let's start off with interoperability. And interoperability is the ability for computer systems and software to exchange and make use of information. So when we think about model-based definition, how do we exchange model-based definition in all of its elements to downstream softwares and tools that we find within our enterprise, across engineering, manufacturing, inspection, and quality? And we quickly realize, and we have a common challenge that many of us face, is the interoperability of engineering data. And how do I go from my model-based definition being in my native Creo to then communicating all that downstream to my enterprise and even my supply chain and all the systems and software that I find within? And we realized that we need to use neutral-based formats like QIF and STEP to bridge that gap as a common denominator to exchange that information. And Capvidia and Belcan have co-authored a blog. You can find that here with the QR code, and you'll have access to this presentation afterwards, on how QIF can improve data interoperability. So if you want to know more, even after the presentation, feel free, it's a good read. So let's talk about the importance of model-based definition. And a lot of you in this room can relate to a 2D drawing being driven by a 3D CAD model. And there's a lot of shortcomings that come with that. Where in a 2D world, the design authority is split across two sources. Where the 2D drawing is the authority for PMI, the 3D CAD model is the authority for geometry, and in many cases, it could be for reference only. The 2D drawing is human readable only, and there's a lot of ambiguity when the human is interpreting this product definition through the 2D drawing. As we move over into a 3D world, into model-based definition, a lot of these shortcomings are resolved. So the MVD is the design authority for both PMI and geometry. The MVD is human and machine readable. And we have clear interpretation of product definition through semantic references. And as you can see through the video, I'll use my pointer here, that as I select pieces of PMI, the semantic references highlight, showcasing the extent of the boundary that's being controlled. So I can exchange those semantic references and share that with downstream software, but also the human can benefit from interpreting the product definition. So MVD is the single source of truth for downstream consumption and reuse. and it is the desired mechanism for exchanging information with downstream software and tools. So creating model-based definition with Creo Parametric has never been easier. With improved MBD features for creating human and machine-readable MBD, we can author PMI to the latest industry standards, which is key when exchanging information with a wide variety of downstream softwares and tools. We have the ability to create semantic PMI for parts and assemblies, and you have easy access to authoring and validation tools like GD&T Advisor, easy tolerance stack-up analysis, and Capvidia's MBD Ready Check tool, where you can validate the machine readability and compliance of semantic PMI before release. So there's a joint presentation tomorrow that I'll recommend that you guys go to between Capvidia and GE Appliances, where they're going to deep dive further into QIF workflows and showcase MBD Ready Check. So now within our presentation, we have trusted and verified model-based definition within Creo Parametric. So next we need to export to QIF. So what is QIF? And that stands for Quality Information Framework, and it is an ISO standard. It's about as far as we're going to go into explaining what QIF is. If you want to know more, Capvidia, Belcan, we're happy to help explain that a little bit further outside the presentation. But here I have my model-based definition within Creo Parametric. And I'm going to use MBD Connect for Creo to harvest and export to QIF. And I'm going to harvest information from the Creo model. I'm going to harvest geometry, PMI across all my presentation states, and key attributes that I need to share downstream. Using MVD, I can automatically generate a bill of characteristics and characterize all the items within the bill of characteristics. And Rudy's going to walk us through that real-world use case here in a few minutes. But before I can leverage my QIF file downstream, I need to ensure that it's fit for use. So using tools like Capvidia, I can validate my QIF file back to my master CAD to ensure that it is fit for use downstream. And now I'll hand it over to Rudy, where he's going to walk us through QIF use cases, where he's going to showcase QIF being used to exchange MBD to downstream softwares and tools.
Thank you, Evan. Everybody can hear me? Yeah, perfect. All right, so we're going to talk about how we can use QIF across the ecosystem. I'll start step by step. We're talking about real use case scenarios here where we can use QIF. First one is ballooning or characterizing your PMI as it comes from Creo over to QIF. Start the video. Let's see.
One more.
There we go. Okay, perfect. So the video will start right now, and it'll show how we're grabbing a QIF file, opening it up in MVD. So this is what you're seeing here is exactly what we had in Creo. You can see that we have all the PMI, but more importantly, we've characterized every single element in the model. So every element now has a tag number or a balloon number, if you're familiar with that. You can see that those tag numbers are also being represented of build characteristics, which is pretty much a list of all your requirements, right? Everything that defines the model is part of that list. Very importantly is we've also subdivided or sub-ballooned those holes. So if you didn't catch it, each one of those holes is actually segregated into a 1.1, 1.2, 1.3. What that means is throughout the workflow, that hole is going to be tagged with that identifier, and you're going to be able to track that throughout. So we'll be talking about that later a little bit more. You can see here that I can also automate the generation of a report. For example, an AS9102 report. It was in the background there. It's an Excel report. And also, we can generate what's called a 3D HTML, which is a lightweight viewable that you can actually open up in any browser and browse through everything that we were seeing there in the 3D model. So These three images here are showing how you have the QIF with your build characteristics, your inspection plan, and your 3D HTML. So making it very easy for someone in the shop floor to use the data for inspection. Another use case or real-world use case is advanced processing of QIF data, like APQP. So in this case, we have the Creo model, which is the original model with all the PMI, exported to QIF, characterized now at this point, and then you can actually grab that data and start to generate DFMEAs, PFMEAs. You can actually use what's called QIF resources and QIF rules. What that does is it actually automates the assignment of equipment. For example, you have a tight tolerance, you can now assign CMM to those tolerances. You have a lighter tolerance, you can assign a caliper. It all depends really on what you need. As for rules, you can also manage some of the types of, once again, inspection sources, but you can also add maybe a different type of inspection route for maybe a tighter tolerance element or something that's been tagged as critical characteristic. And you can complete the workflow and push all that data that you recover up to the PLM. And we'll talk about how you can use that data to make decisions in the future. Okay. One very important portion of using QIF information, once again, highlighting how we're going from the Creo model to a QIF standard inside MVD Video. This QIF file can actually be consumed by most of the larger CMM softwares. What that means is you're automating a lot of the process, which is typically done manually. But in this case, a CMM software will open up this file. It'll start to recognize all the features, and it will start to understand that hole 1.1, that should be a certain diameter. It's a positional tolerance. So you're starting to really automate this process. No longer are you having issues of somebody typing in something differently. So I want you guys to start to think about how you can really automate this process. Once again, this is where we see the highest return on investment when implementing MBD in the real case. It's just having this direct transition from a CAD model all the way down to the CMM. Okay. In a similar way, we can also implement visual inspection using MVD Video, QIF, and so on. I'll start this video. So QIF is a software company we are also partnering with, and they specialize in inspection software for visual inspection processes. What we're showing here is this QIF model is actually tagged inside Creo to have specific areas where you're going to be checking for some kind of visual condition. You have a criticality to check that blade for some kind of scratch. Software QIF will actually grab that QIF file, the standard format file, bring it into their system. You can see the robotic arm going through the inspection right now and start to inspect this. It's doing whatever a human would be doing, right? Instead of having some operator looking for scratches, it's actually going to a control process to understand what could be a potential issue in those critical areas, right? So this system can also check, for example, a label that's placed incorrectly, maybe hardware that's not placed where it should be, so you can really extrapolate where you can use this visual system. More importantly is that data can be brought back into MVD Video, and you can actually see how the data is pretty much linked to that MVD. Now you have hey, this section we find a scratch here in this section, in this critical area. You can click on that section and it'll bring up that picture of what it found, making it a actual digital twin of what you designed and what was built. So in this case, you're doing visual inspection in this scenario. Okay. So similar to CMM or the visual inspection, we can also manage welding. So you can define you can define welds in Creo as you would in assembly. Define and put your PMI in there. Export them to QIF once again. We would recognize those welds, characterize those, and then they can be pushed into a production system like this software here, which is Delphi. They can read the QIF data, the standard format, and actually program the machine to do the welding. So once again, automating all this process. We're trying to eliminate as much human involvement as we can. And really, in addition to automating the production process, you're also including the inspection process as well. We can do an inspection plan specific to welding that could be placed in parallel with this production system. So you're kind of generating two paths, production and inspection in this case. And then finally, kind of closing the loop here is the data that we recovered, not only manual inspection, we recovered in CMM and visual inspection, can all be brought into MVD Video. As you're recovering data, you're putting that data into this QIF format, opening it back in MVD Video, and using that data to really analyze what's happening with the S-build component. So in essence, really having a digital twin here. So this data can now be used to make decisions. You can have people up in design, engineering, really looking and understanding, wow, that 1.2 hole that's on the lower left-hand corner, it's been moving to the right. What could it be, right? They can actually see what's happening. Do we need to change tolerance? Do we need to change something else? But they can actually use this data in an easy way to visualize and understand what's happening, the trends, and use it for making decisions. All right, so just a last time review of all the scenarios where you can use MVD by using the medium as QIF as the medium to transfer your data, MVD Video as the way to review the data and actually characterize your PMI. But we have ballooning, making plans, advanced workflows like we talked about, APQP. We have CMM, and scanning, visual scanning. CMM, once again, is one of our highest return on investment processes. Welding, and just, once again, using that data for making decisions at the end when you're reviewing your in-process data. So great. Evan, if you want to continue here.
Yeah, thanks, Rudy. I think these are all really good use cases of extending and leveraging and exchanging MVD to downstream using QIF. But more importantly, it's all stemming from the Creo MBD, right? So extending that digital thread out to all these various different use cases. So hopefully you guys found some value in that. So let's talk about starting your digital transformation journey. And I'm sure there's a wide range of you in this room that are either on a journey, getting ready to start a journey. But here are some bulletized points that we would like to provide to you. So first one is understand your downstream MVD reuse and also your downstream audience. So where within your organization, the domains of your organization, would you like to leverage in reuse model-based definition? And that is key to the next one, which is establishing a cross-functional team. So understanding your downstream reuse, find champions within those domains that can help guide and implement your digital transformation. Consider running a pilot to prove value, right? So you don't have to do this alone. Use your cross-functional team and also subject matter experts. Consider joining industry working groups. Right? There's a lot of like-minded people out there on a digital transformation journey just like you. There's working groups within the DMSC, within ASME, and also on LinkedIn with the MBE and MBD Nerd Herd. If you haven't heard of that one, look it up. And then secure leadership support. And I'd say that one's really key. So once you've understood your downstream audience, right, it's difficult to implement a digital transformation from a bottoms up, especially when you're trying to change people and culture. So once you've understood your downstream audience, ensure that you have leadership buy-in so you can start to implement your digital transformation from a top-down approach, ensuring that you have people, process, and tools all advancing at the same rate. And then the last one here is that you're not alone. So work closely with subject matter experts. And Belcan, Capvidia, we're all staffed with subject matter experts to help you wherever you're at on your digital transformation journey. So with that, we'll open it up to questions. We got about 10 minutes left in the presentation. Any hot burning questions? Yeah.
Well, I'm not sure how relevant this is, but how would this work in a multi-CAD environment? Is that something that...
Multi-CAD? Yeah. Well, I think with QIF being a neutral format, yeah, QIF, you guys have QIF plugins for...
Yeah, we can plug into NX, CATIA, Creo, of course, SolidWorks. Let's say, okay.
Yep. And then once you're into QIF, being that it's a neutral format, as Rudy presented on, there's a lot of softwares within the metrology domain that are accepting QIF to extend that digital thread all the way through, right? Minimizing the amount of human interaction interpretation that's happening. We don't want to completely remove the human, but it's less manual work that has to be done. I don't know if you guys want to come. Are we supposed to use the microphones?
If you guys can,
But if you can speak loud
enough.
enough.
Yeah, go for it, yeah.
Yeah, so question would be, how would I do configuration management of that QIF that I generated for versioning, updates, changes?
So we do have a way of managing revisions with QIF. We have our software MVD video allows you to grab Rev A and actually compare it to Rev B, and it'll tell you what the differences are between Rev A and Rev B when it comes to PMI, anything that's been added. When it comes down to the actual file, you would just manage it like it's your PLM. It's an actual file that you can either attach it and as part of an attachment, but it's really like that. But we do offer a tool to compare, so yeah.
Yeah, and I'll add to that too, that there's also enterprise level solutions for generating QIF within your PLM. So if you're going from Rev A to Rev B, you can pull down Rev A, generate a Rev B, and it'll manage all that change with revision control. Keeping intact, so which also is key, is that the characterization that's happening, the ballooning, those remain intact throughout the product's life cycle. So as you generate all these reports that all the humans and in metrology are using, right, you have the same traceable artifact all the way through the life cycle.
Couple of things. The QIF gets tacked on or piggybacks on the CAD document convention, I hope, right?
It can, yes.
Now you have the ballooning. If I delete, how does that balloon affect, or does it show?
Yeah, if you do a comparison, sorry, you can hear me. If you do a comparison, it would show you that balloon was crossed off. Similar to in 2D drawings, I would just say X off, deleted. But that number would stay locked out. Like you wouldn't want to reuse that number.
Correct.
Yes.
Gotcha, because if that's a UUID with that,
it is.
I may have NPM to create inspection plans. I know short presentation, but that was the general question leading into it.
Yes.
As we use Windshield to create NPM and inspection plans, how does what you showed us, which is pretty cool, kind of marry with that?
Yes, no, and if you have more questions, feel free to stop by. We can talk about that. But yes, exactly. You want to, the linking is you want to keep those characteristics the same throughout the workflow. And what QIF is doing is managing that using UUIDs. So inside the hood, per se, you have that control there. Sure.
If the QIF has the UUID, the Creo doesn't know about it.
It doesn't, but we can make a connection if we have to, yes.
There are working groups out there within the DMSC that are working on how to characterize within native CAD tools.
Yes.
Characterization is currently happening today within the QIF file.
If we do like a bad version of it with the tagging stuff. And
Instance IDs are very difficult to do. But again, the joint presentation tomorrow with GE Appliances, I would encourage you to go. If you want to know more for everybody, they're going to talk more about real world application. And
go into detail, I think.
Yes.
On that. But yes, we could definitely talk about it.
Yeah, people are doing this in real life. So it's, oh man, we got it.
Nice.
Yeah, we'll go here first and then here.
How does QIF work for CAM software? Is it a direct replacement for step files?
We are, it's not being used currently for CAM. You know, the intent was for quality, as quality information firmware. we are getting a lot of interest to use QIF because there's a backbone to it, right? Getting all the characteristics, potentially driving some of your CAM approaches based on tolerancing. So it's something we're working through. We're trying to get some relationships with some of the CAM software companies so that they can understand how they can use the QIF file. But currently in process, I would say.
But all the right elements are there, so it's
Yes. Yeah.
should be fairly simple to implement. It's easy for me to say.
Sorry, just to elaborate. I guess my question really is for subcontractors that aren't maybe able to use native files.
Yes.
You're forced to use the step files as well as the QIF, possibly have information. Yes. So they both contain model-based definition.
Yes. Yeah, so I think the tendency is we're seeing both being delivered as a TDP, either a step and a QIF. The step is intended for essentially maybe for use in your in-process design work, and for CAM, QIF is being used for the downstream consumption and inspection plans and CMM inspection. But I think we're going to start to see more interest in maybe using it as well for CAM. So.
My question was somewhat similar, that QIF and STEP are both in ISO.
Yes.
And I've understood that STEP is starting to implement, or planning to implement some of the features of QIF. So how do you see that going? Are we going to have to support two?
It's a format war.
So we support both. There's some things that QIF can do that we couldn't do in STEP. There's a little bit of time delay to issue right now with STEP, maybe getting to implement these things that we're doing with QIF. I guess it all depends on your implementation and how your supplier base is working on how to provide. What we've seen is people actually supporting, sending both at this point.
Yeah, I think they both have their place right now, but I think eventually they're going to converge, and you have to choose which format you want to support your supply chain or your enterprise.
It's like Coke and Pepsi.
And then we had a question back here, yeah.
Yeah, I was curious if you had a single visual thread connection, a solution for programming sheet metal lasers and creating brake programs for press brakes.
So we did an implementation. You saw the welding implementation, right? Did you get a chance to see the Delphi, how we bred in the PMI for actually applying bead welds? So we have that implementation. We can work and do an implementation for something like sheet metal, but it would require, it's just some development work. We don't currently have something that we can use. But we could talk about if there's something, some interest and some benefit that, yeah, definitely we can do that.
Here. Oh, so we'll go there next, sorry.
So I think you mentioned the highest ROI use cases.
Yes.
CMM.
Mm-hmm.
How does that compare with scanning or some of the visual inspection use cases?
So I think the question there would be is typically most people will have a manual inspection or a roamer arm or CMM that does touch probe inspection, and we see the benefit of just grabbing that data directly and using it. When it comes to actually inspection and scanning, there's more data to be processed. So we do see some benefit, or meaning there is some improvement there when it comes to actually creating an inspection plan and potentially creating that feature to surface profile and inspect this. But it really comes down to how you're using that inspection data. Like, are you post-processing that inspection data in a certain way?
Yeah, I'll add to that, and
Yeah.
I would say that like 3D scanning, blue light scanning, CMM, paracalipers, it comes down to the right tools to do the job. And I think it gets into QIF resources. But QIF directly into your metrology software is automating the process that the human would usually do to automate and set up that template. Pairing that with 3D scanning is obviously a really good pair for visualization and doing 3D metrology, right? Rather than I guess it's all really point-based, but point-based with a CMM.
Yeah.
So.
And one thing to highlight though is that we get this question all the time, is we're not pushing everything to the CMM here, we're just making the data available to be consumed. It could be consumed by a CMM, scanner, a caliper, an operator looking at that 3D HTML and seeing, oh, I need to inspect this with a caliper. So we're trying to make the process more efficient, not just create a bottleneck at CMM.
So I think one last question, yeah, and then I think we're at time.
Yeah, I'm curious, the settings, when you're exporting and importing the QIF, do you have a similar type of filters that you have with step 2 or 2? And then for the surface information, are you still managing it using something like the insertion value inside the step file that manages the actual resolution of the geometry? Is there, because that can get you in trouble if you don't match them up when you do the exporting and import, so you might wind up ruining the geometry. Is it more foolproof than step file?
It's a perfect question to end on. I'll let you handle that one.
Okay, perfect. I may not have the correct answer, but or the full answer, I would say. But yeah, it should be the same type of filters that we have with STEP. We've had same success with one and the other. We did highlight our software called Capvidia, which does the validation between the QIF file, geometry, PMI, and so on, directly to the CAD. So it will tell you, it will do a point-to-point analysis at the surface level to confirm that that's matching your source data. So that's kind of on the validation side. But definitely stop by the booth later today and we can dive into those settings if you're specifically looking for some kind of setting that you need to for your process. Yeah.
Great. Well, thanks everybody for being here, and hopefully you enjoy LiveWorx 2023.
Yeah, have a good one, guys.